Right, so lecture 25 about the unit circle. Okay. So in this lecture, we're gonna learn two very big things about the unit circle. First, to identify the reference angles. I will show you what to do with that. And determine terminal points on the unit circle. I will tell you again, terminal points and how to find those on the unit circle. Okay, you move. Okay. So here you have a unit circle. So the unit circle is a circle with radius 1. Okay. So here I'm gonna draw something here. Okay. So this radius is 1. So the unit circle is the circle center at the origins and with radius 1. You remember in lecture 3 when we first introduced the degree measure or the radian measure, um, or angle measure in general. When you start the angle at this side, which is called the initial sign, and you end up at certain side, that is called the terminal sign. And on the terminal side, you have a point on the unit circle. On the circle is called terminal points. Okay. So in this is angle, again, positive rotation is counterclockwise. So this is the angle theta. And this point you see here is the point x comma y is the terminal point. And if you project this point onto the horizontal axis or the x-axis, y-axis, this is the origins. You will see this. This is the right triangle. Is form a right triangle inside the unit circle. And this part is x value. And this side is the y value. Now the next thing we're going to do is to do some calculations related to this angle and the unit circle. And we're going to use the trigonometry ratios that we just learned in the last lecture to calculate the value of cosine of theta and sine of theta. Now for cosine of theta, we do the adjacent over the hypotenuse, right? So the adjacent of theta is x, and the hypotenuse is 1 because of radius 1. So obviously, x is equal to cosine of theta. So I want to do this calculations in order to say that this axis is the horizontal axis or the x-axis, but in terms of trigonometry, this axis is called the cosine axis. So let's do something similar to sine. So sine of theta. So sine is the opposite over the hypotenuse. In this case, the opposite is y. 1. So y equal to sine of theta. So this showed that so the vertical axis is also the y-axis. In this case, in terms of trigonometry, is called the sine axis. And the point you see, the terminal point is x comma y. Right, obviously, the point consists of two components, x component and the y component. For x is equal to cosine of theta and y is equal to sine of theta. There's another name for this type of point. It's called the reference points. which later on lead me to the definitions of reference angles. Okay, but for now it's reference points. Okay. Again, reference point consists of two components, x and y, for x is equal to cosine of theta, and y is equal to sine of theta. Okay, good. So let me stop right here. We will continue with this one. Have a good day, everyone. Thank you for being here. Enjoy the eclipse. So for lecture 25, we start looking at the unit circle. Again, the idea is that we want to know how to calculate or find or locate the reference angle and also the reference points on the unit circle. We did some calculation yesterday to show that the horizontal axis or the x-axis of the time in trigonometry is considered the cosine axis. The vertical axis, the y-axis, is also considered the sine axis through this calculations. And the calculation or this particular ratio is from the last lecture on 24, where you have the cosine of an angle is the adjacent over the hypotenuse. In this case, the hypotenuse is the radius of the circle, which is equal to 1. And sine of an angle is the opposite over the hypotenuse. So therefore, you have x equal to cosine of theta and y equal to sine of theta. And for the reference point, there's always two components, x and y, and it's corresponding to cosine of theta, and y is corresponding to sine of theta. Now, let me move on to something called trigonometry identities. So this trigonometry identity is, it sounds fancy, but it's very simple. It's coming from the concept of the equation of a circle. Okay. And the equation of the unit circle specifically is x squared plus y squared equal to 1. Or even more specific into how to get that x squared plus y squared equal to 1. If you look at the right triangle here and you apply Pythagorean's theorem, you get that. So x squared plus y squared equal to 1. Or equal to 1 squared for that matter. So by the Pythagorean's theorem, you have what? X squared plus y squared equal to 1. So that's the equations of a circle center and the origin with radius 1. Okay. Or more specifically in our case, the unit circle, equation of the unit circle. Now, the trigonometry identity I want to show you here relates between sine and cosine with 1. So x is related to cosine of theta, y is related to sine of theta. So therefore, instead of writing x and y, I'm going to substitute that with sine and cosine. So x will now become cosine square of theta plus y square, which is sine square of theta. And this is equal to 1. Now, so that's one identity. Another identity I want to show you is a quick proof here. If you divided both sides of cosine squared theta, again, divided both sides for cosine squared theta, this is what you're going to see. You have 1 plus sine square of theta over cosine square of theta equal to 1 divided by cosine square of theta. Now, what is sine theta over cosine theta equal to? Remember from yesterday. Tangent of theta. So instead of sine square over cosine square, you can rewrite this as tangent square of theta. You would know that. Okay. Now, 1 over cosine of theta, what is that equal to? Secant, right? So instead of 1 over cosine square, I can rewrite this as secant square of theta. So that's going to be another identity from the equation of the unit circle. Okay. All right. So let me rewrite this a little bit. So here you have sine of theta over cosine of theta altogether square. And this is 1 over cosine of theta altogether square. So hopefully it's help you recognize the formula, the relationship between tangent of theta with sine and cosine better, and the relationship between secant and 1 over cosine of theta better. So here I can rewrite this as tangent square of theta equal to secant square of theta. So I have one equation. I want to box it. There's another equation. All right, so two identities. There's another identity I want to show you here, also coming from this original identity that we have, cosine square of theta plus sine square of theta equal to 1. Now, here for these derivations, what we did is we divided both sides for cosine square of theta. For the next identity, what I want to do is I divided both sides of this equation for sine square of theta. Good. All right, so I have a little bit of space on the left-hand side here. That's what I'm gonna do. So I start again with cosine square of theta plus sine square of theta equal to 1. And now I divided both sides for sine square of theta. So I have cosine square of theta over sine square of theta plus 1 equal to 1 divided by sine square of theta. Now, similar to the last derivations, what we do is we look at the relationship or look at this ratio and relate it back to tangent, cotangent, secant, cosecant. Okay, so cosine over sine is going to be cotangent theta. So this term becomes cotangent square of theta. And 1 over sine is cosecant of theta, or on the right-hand side, you're going to obtain cosecant square of theta. Okay. So here you have cotangent square of theta plus 1 equal to cosecant square of theta. Good. So hopefully you know where this identity coming from. Again, it's from the equation of the unit circle or the Pythagorean theorem. Okay, and then you just swap x with cosine of theta and y with sine of theta. Now for the second identity, what you do is you divided both sides for this equation for cosine square of theta, and then just manipulate the ratio to get to this identity. Similarly, for the third identity, you divided both sides of this equation for sine square of theta, and again, manipulate the ratio to arrive at the answer. Okay, so that's the three very important trigonometry identity that again, if you in the sciences, you will see this over and over again. Okay, next. So because eventually we're going to work with reference points on the unit circle, right? And the points always consist of x and y, or cosine of theta and sine of theta. And sometimes or often we really want to know the sign of cosine of theta and the sign of sine of theta. See that really fast sometimes. Right. So when you look at this unit circle, the unit circle is broken down into 4 different quadrants. Okay, so quadrant 1, 2, 3, and 4. Right, so you see something like this already. So this one is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Now, for each quadrant, you have different sign for x and y. So here in the first quadrant, x and y are both positive. You with me on that? So cosine is positive, sine is also positive for the first quadrant. Now move on to the second quadrant. X is positive. X is negative and y is positive. That means cosine in the second quadrant is negative and sine in the second quadrant is positive. You good? Move on to the third quadrant, x and y are both negative. So cosine is negative, sine is negative. In the fourth quadrant, x is positive, y is negative. Similarly, cosine is positive, sine is negative. Good. Okay. With that in mind, we can actually derive the negative or positive part for tangent and cotangent, secant and cosecant depends on the sign of cosine and sine. So here for the first quadrant, cosine is positive because that's the x value. Y is, or sine of theta is positive. And from here, you can derive the sign for tangent, cotangent, secant, and cosecant as well. So this is positive, they all positive. So tangent again is sine over cosine, so positive over positive give you positive. Cotangent is cosine over sine, so positive over positive give you positive. And you do the same for secant and cosecant. Any questions here? Now for the second quadrant, right? So x is negative, y is positive. So the x part or cosine part is negative, and sine part is positive. So now tangent is going to be negative. Cotangent is negative, right? Now secant of theta is 1 over cosine. So 1 over a negative number should be negative. Cosecant of theta is 1 over sine. So 1 over positive. It's going to be positive. Now for the third quadrant, both sine and cosine are negatives. And because they're both negative, therefore tangent should be positive. Cotangent should be positive. So negative over negative become positive. And secant is 1 over cosine. So this is negative, and this is negative as well. In quadrant 4, you have positive for cosine. Sine is negative. So this is negative, negative, negative for tangent, negative for cotangent. Now for secant of theta is 1 over cosine, so 1 over positive will give you positive. And this is negative because 1 over sine or 1 over negatives give you negative. Any questions? Cool. Okay. So I'm gonna give you some scenario here where there's a point on different quadrants. You will see one coordinate or one component is given, the other component is missing. You need to identify the missing component of the points. Okay. Now it's very important to recognize the location of the point on whatever quadrant is given to you, right? Because you may have a different result depending on the point. Okay. So here, the first point, quadrant, this point is in quadrant 4, even I can't see it from this quadrant 4. All right, so the first component is root 3 over 2, and the missing component is y. Okay. So it's look complicated a little bit, but it's just we just going to use the Pythagorean theorem to actually solve for the missing component. All right. So remember, this is the unit circle. So you start with the unit circle, x squared equal to x squared plus y squared equal to 1. Again, this is the unit circle or the equation of the unit circle. You know the value of x, so substitute that into the equation. So you get root 3 over 2 square plus y square equal to 1. So root 3 over 2 altogether squared give you 3 for the numerator divided by 4. So 4 is in the denominator. Plus y square equal to 1. And now this is the job for us to solve for y square, or to solve for y for that matter. So y square becomes 1 minus 3 over 4. 1 minus 3 over 4 give you 1 over 4. Now you have y squared equal to 1/4. Then you take the square root on both sides of the equations. What do you get? Square root of 1 over 2, right? 1 over 4, I should say. Or in general, is 1/10. Okay. But you need both plus and minus in this case because you solve the solution of the equations. So when you take the square root on both sides of this equation, you get plus and minus 1/2. Okay. You get the idea? You know where's the plus and minus 1/2 coming from? You good? Okay. But now you cannot just take two values here. Look at the quadrant that is in. So in quadrant 4. So in quadrant 4, what is the sign of y? Is that positive or negative? Negative. So the answer in this case should be y equal to -1/2. Okay. So you say that since the point is in quadrant 4, y is equal to -1/2. And you say the point is root 3 over 2, comma, -1/2. All right, let me move on to the second question. So in this case, x is missing and the given component is y. You get 1 over root 2. And this point is in quadrant 1. Okay, so same approach here. You start with the equation of the unit circle, x squared plus y squared equal to 1. Substitute in the known component and solve for the missing component. And then depend on, usually you're going to see two values of x or two values of y. But depends on the quadrant, you will choose the appropriate answer. Okay, so let me do part B again. So you start again with x squared plus y squared equal to 1. So this is the equation of the unit circle. So x is missing, right? But you know y. So 1 over root 2 squared equal to 1. So 1 over root 2 squared is going to be 1/2. So x squared plus 1/2 equal to 1. You solve for x squared. Again, 1 minus 1/2 equal to 1/2. Then you take the square root on both sides of the equation. You should get plus and minus 1 over root 2. So what value should I choose here? Do you know where's the 1 over root 2 coming from? Yes, no, no. Okay. So you have x squared equal to 1/2. You okay with this step? Now you take the square root on both sides. You should have plus and minus. This part is fine, right? Square root of 1 over 2. You okay with this? Okay. So how could I arrive at 1 over root 2? So there's another way to write the result. This is root 1 over root 2. You're okay with that? So root 1 is just 1. Okay. Basically, I skip 2 steps. You're okay with the results. You know where it's coming from. Good. Now, what value should I choose? Should I choose positive or negative? Right, why that is the case? Because x positive. Right. So because the point is in quadrant one, so x has to be positive. So we choose x to be one, positive 1 over root 2. So since the point is in quadrant one, you have x equal to 1 over root 2. So the point is 1 over root 2, comma 1 over root 2. So yesterday I say that you can just write 1 over root 2, but by conventions, usually it's written as root 2 over 2. So, or you can represent this as root 2 over 2. Right? Basically, it's just radicalize the results. Again, either answer should be fine. Not worry about it. It's just I want to show you there are some options for you to answer. Okay, so I have 2 more problems here for this example. Can you spend a little bit of time on these 2 problems? Can you try to mimic what we already have so you can get the same answer or a similar answer? Good. All right, so let me quickly do part C. So again, let me start with x squared plus y squared equal to 1. So the missing component is x. Right. So you do x squared plus negative 1/2 square equal to 1. Okay. So you have the entire negative 1/2 square. Okay. So negative 1/2 square become positive 1/4. That. Okay. And then you can solve for x squared. That is x squared equal to 1 minus 1/4. Well, this is 3 over 4. So x squared is equal to 3 over 4. Therefore, when you do x, you get plus n minus square root of 3 over 4. Or you do plus and minus root 3 over root 4. For root 4 is equal to 2. Right. All right. So now you have to choose one value. So the point is in quadrant 3. So x has to be a negative number. Okay. So since the point is in quadrant 3, you have that x is equal to negative root 3 over 2. So the point is negative root 3 over 2, comma, negative 1/2. Any questions? All right, the last part. Again, you start with x squared plus y squared equal to 1. Here you get negative root 2 over 2 square plus y squared equal to 1. So negative root 2 over 2 give you 2 over 4 plus y squared equal to 1. Or 2 over 4 is 1/2 plus y squared equal to 1. And then you can solve for y squared, that is 1 minus 1/2 is equal to 1/2. Right. And then you take the square root on both sides of this equation. So very similar to what we have on the board here, except now you have y squared equal to 1. take the square root on both sides, you should have plus minus 1 over root 2. And the point is in quadrant 2, therefore y is positive. So sin. The point is in quadrant 2. Y is equal to positive 1 over root 2. So the point is negative root 2 over 2, comma, positive 1 over root 2. Again, this is fine to write like this, but by conventions, I need to radicalize the second component. And I get, well, you can write this negative root 2 over 2, comma, root 2 over 2. Any questions? Any questions? So we're going to move on to something else. So why are we doing all of this, right? So the idea is that at the end of this lecture, with all of the information that we collect so far, including lecture 23, lecture 24 yesterday, the ratio, whatever we're going to do, we could be able to fill out all the information here. We're starting from a 0 degree angle, moving to 30 degree angle, 45, 60, 90 degree angle, so on and so forth. And we will fill out all of the special angle and their corresponding reference points or terminal points for that matter. So the reason for that is when I first introduced you this table and I have this row to be signed, because it is actually easy to learn about sine of 0, sine of pi over 6, sine of pi over 4, so on and so forth, rather than cosine. But now I switch it back to cosine first and then sine row, because due to the fact that the point, the reference point or terminal point on the unit circle consists of two components, the x component and the y component. So that is the cosine comes first and then the sine. So that's the reason for the switch. All right. So having said that, I'm gonna review this table together with you, and then we're gonna work together on the unit circle a little bit later. So for radian, I'm gonna convert between degree measure and radian measure. So 0 here, pi over 6, pi over 4, pi over 3, and pi over 2. Again, this is very similar to the question in the quiz that you had. So cosine of 0 is 1. Cosine of pi over 6 is root 3 over 2. This is root 2 over 2. This is 1/2. And this is 0. Now you just take all of this number and then mirror it. You should have, this is 0, this is 1/2. This is root 2 over 2. This is root 3 over 2. This is 1. Now, tangent of theta is sine is the ratio of trigonometry ratio, right? So sine over cosine. So in this case, you do 0 over 1, you get 0. You do 1/2 over root 3 over 2, you're going to get 1 over root 3 or root 3 over 3. So this is 0. This is root 3 over 3. This is 1. This is root 3. And this is undefined. Because again, the reason is that you do the ratio of sine over cosine, so 1 over 0. You don't want to define 0. So that is undefined. Now, again, you take this result and you just mirror it at 1, right? You should have, this is undefined. This is root 3. This is 1. This is root 3 over 3. And this is 0. And the questions on this table, right? So hopefully you're familiar with this table. Now we're going to fill out the unit circle. Not only the special angle that you see in the table, but also other special angles that you can derive directly from the angle in the first quadrant. Okay, so I'm gonna start with the zero angle, and then I move on to pi over 6, pi over 4, pi over 3, and then pi over 2. And everything else will be derived from the first quadrants, all the angles from the first quadrants. All right, so here's what I'm going to do. So I'm gonna start with 0 degree or 0. Right, so one is degree measure, the other one is radian measure. And remember, the point consists of the x value first and the y value. So cosine and sine. So the first point, I'm gonna use a different, let me use a different color here. So this point is 1, 0. So x, right? So the measurement here is 1. That is on the x-axis, so the y value is 0. Do you remember the trick using your left hand that I showed you the other day? So you can use that for the unit circle, right? So this is the ring finger, right? This is the middle finger. This is the index finger, and this is the thumb. Okay. Now, so let me fill this out first. So the next angle should be 30 degree or pi over 6. The next one is 45 degree or pi over 4. The next one is 60 degree or pi over 3. And the last one is 90 degree or pi over 2. Now, the only formula that you need to memorize for the point is square root of n over 2. Depends on how many fingers, right? Below or above. So here's one more thing I want to explain this. So here, starting here for the zero angle, which is again the pinky finger, how many for cosine, you count how many fingers you have above that. So 4 of them, right? So square root of 4 over 2, or 2 over 2 is 1. The first entry is 1. And for sine, you count how many fingers you have below, right? So here, the pinky finger, there's no fingers below that, so that should be 0, square root of 0 over 2, so 0. Now for the ring finger, you have, how many fingers you have above it? So 3. So square root of 3 over 2 for the first entry, right? And for the second entry, there's just 1 finger below it. The square root of 1 over 2, so 1/2. That's for 30 degree or pi over 6. Now 45 degree angle in or pi over 4, you use your middle finger. Right, you have 2 fingers above that, so square root of 2 over 2. You have 2 fingers below it, so square root of 2 over 2 as well. Now 60 degree angle or pi over 3. You use the index finger, so 1 finger above that, so square root of 1 over 2, so 1/2. And then 3 fingers below it. So that would be, here is 1/2, here is root 3 over 2. And for 90 degree angle, you use the thumb, right? No 0 above the thumb, so that could be 0. And 4 fingers below the thumb, so square root of 4 over 2, or 2 over 2, or 1. So this one is 0, 1. So at this point, I hope that you should get yourself familiar with all of this angle. how you generate all of these components. All right. Now for the rest of the unit circle, here's what you're going to do. For each angle in the first quadrant, you add 90 degrees. You can generate the rest of the circle. Okay, all the special angles. Circle. Now you start at 0 degree, you add 90 degree, of course you add 90 degree. You with me on that? 90, you add another 90, you add 180. Another 90, you add 270. Another 90, you add 360. You with me on that? Okay. Now for 30, you add 90 degree, you add 120. Four, you add another 90, you add 210. And then a 90, you get 300. Then you get it. Okay. Then you move on to 45 degree, you add 90 degree, you get 135. Okay. Add another 90 degree, you add 215. Okay. And then another 90, what do you get here? 305. Yeah. Then that's it, right? So on and so forth. You with me on that? That's how you feel all the angles in the unit circle. Starting with the first quadrant and just keep adding 90. Cool. All right. So that's what we're going to do for the circle first. I'm going to use a different color here to distinguish between the angle in the first quadrant with the second and the third and the fourth. All right. So here is starting from 30 degree, you add 90 degree. What do you get? 120. Okay. Or this is 2 pi over 3. So I trust that you should be comfortable with switching between the angle measure. Right? So from 1 degree measure to radian measure. And then you have 45 degree, you add 90, then you get 135 degree or 3 pi over 4. 60 degree, you add 90 degree, then you get 150, or this is 5 pi over 6. And then 90, you add another 90, you get 180 degree or pi. Right, so you're done with 0, you're done with 30, you're done with 45, 60, 90. The next angle is 120. So you take 120, 90 degree, you get 210. Or this is 7 pi over 6. Then 135, you add 90 degree, you get 225 degree. Or this is 5 pi over 4. And then 150, you add 90, you get 240. Or this is 4 pi over 3. And from 180, you add 90 degree, then you get 270 degree. Or 3 pi over 2. Then you just keep going, right? So 210 plus 90 degree, you get 300 degree or 5 pi over 3. So 225 added with 90, you get 315. Or this is 7 pi over 4. And then 240, you add with 90, you get 330. Well, this is 11 pi over 6. You okay with that? So hopefully I just show you and you comprehend how to fill out the unit circle, all the spectrum. Now, what about corresponding terminal points on reference points? So here's what to do. One, remember the sign of x and y on each quadrant. So in the first quadrant, x and y are positive. In the second quadrant, x negative, y positive. Okay with that. The third quadrant, both of them are negative. In the fourth quadrant, x positive, y negative. Okay. So you utilize that fact and then just fill out the rest of the term. Okay. Now let me start with something easy first. So the point at 180, so 1, 0, you flip it to this side, right? It should be -1, 0. Okay. Now for this point, 270 degree, you with 0, 1, you flip it to the other side, it becomes 0, -1. You're okay with that? So this is -1, 0, and this is 0, -1. Now for the point at 120 degree, corresponding to this point, okay, it's just that the x value becomes negative. You with me on that? All right. So this point should be at -1, √3/2. -1/2, √3/2. But the point at 135 corresponding to this point, √2/2, √2/2. Right. Just bring that to the other side. Now the x value becomes negative. So this is -√2/2, √2/2. The point at 150 corresponding to √3/2, 1/2, but the x value becomes negative. So you get -√3/2, 1/2. Then we already get the point at 180. Now for the point at 210, corresponding to this point, right? But both x and y are negative, so the point should be this should be -√3/2, -1/2. The next point is for 225, corresponding to the point here, right? So -√2/2, √2/2, but both of them should be negative. So you should have -√2/2, -√2/2. And then hopefully at this point you recognize the pattern, how you obtain the points. So here is -1/2, -√3/2. So you got the point at 270 degree already. Now for the point at 300, So this corresponding to this point, right? But the y value is negative, x value is positive, right? So the x value is here 1/2, the y value is negative, so √3/2. The point at 315 should be √2/2, comma negative √2/2. And the last point is √3/2, comma negative 1/2. And of course, 360° or 2 pi should have the same point as 0.